Welcome to myproductbazaar.com. Let me discuss about the project Self-Supervised Online Metric Learning with Low-Rank Constraint for Scene Categorization. Let me discuss about the project Self-Supervised Online Metric Learning with Low-Rank Constraint for Scene Categorization. The overall process is dividing into testing and training. In the testing phase, the input image is first pre-processed. Filtering and gray conversion is done using the pre-processing step. For filtering, we are using Gaussian filter. The color and the shape features were extracted from the image. For this feature extraction, we are using GLSM algorithm, Gabor algorithm, and Shift algorithm. Then the images were classified based on the features extracted using a classifier. For classification, we are using KNN classifier. Then analysis is done for the classifier. In the training, the same process is repeated for all the images in the database. Finally, the performance of the classifier is measured. The main advantages of this process are here. The process produces high efficiency comparing to the existing algorithms, and then the process is very effective, and the accuracy and the confusion matrix shows that the process produces better results when compared to the other algorithms used. And also we are using 3 feature extraction algorithms so that accuracy is improved. Let me discuss about the flow of the project Self-Supervised Online Metric Learning with Low-Rank Constraint for Scene Categorization. In this process, initially the input image is pre-processed. For pre-processing, we have used Gaussian filter. Precious bits were wasted on a noisy image, so pre-processing is an initial basic step in all image processing process. In this process, the images are Gaussian filtered in order to remove the unwanted pixels within them. Then, pre-processed images where feature extraction is done from the pre-processed images. For feature extraction, we are using 3 algorithms: GLCM algorithm, Gabor algorithm, and then Shift algorithm. So, color features were extracted using GLCM algorithm. GLCM is a tabulation of how often different combinations of pixel brightness values occur in an image. GLCM textures contains the relationships between the pixels at the time called the reference and the next pixel. The reference pixels have the same range of variations with the neighboring pixels, so that the values among the top identical to the values along the side. The diagonal elements represents the pixel pairs of the gray. The diagonal elements or represents pixel pairs of gray level difference. The farther away from the diagonal, the greater is the difference between the pixel gray levels. The resulting values were saved as then Gabor feature extraction. In this, shape features are extracted using Gabor filter. Gabor filter possesses the optimal localization properties in both spatial and frequency domain. The impulse response of these filters is created by multiplying a Gaussian envelope function on complex oscillation. The phase difference of the left and the right filters responses to the estimate the disparity of the input images. The resulting features were saved, and also shift features were also extracted and they are saved. Shift feature represents the visible clear edge values present in the image. The values are saved in a table format, and then they are passed into the classifier. Before that, the database that contains the images is trained by extracting the same feature extraction algorithms for all the images. The classifier now classifies the input image. Classification of the images is done based on KNN classifier. An object is classified by a majority vote of its neighbors. KNN classifier operates on the premises that Classification is an unknown instance can be done relating the unknown, the known, and according to the some distance or similarity functions. Two instances for about in instance which defined by the appropriate distance functions are less likely than two constant instances to belong to the same class. The nearest neighbor is located in the instance space. The unknown instances are labeled with the same class and are labeled as that of the locator. Then the classified recognized result is got, and based on that a confusion matrix is plotted. The confusion matrix or a matching matrix is a tool that is used to validate the accuracy of a classifier. A confusion matrix is a specific table layout that allows the visualization of the performance of an algorithm. Each column of the matrix represents the instances in a predicted class. Each row represents the instances in an actual class. The accuracy of the algorithm ranges from 84 to 90 depending on the size of the training set. Now let me see the execution of the process. Self-supervised online metric learning with low rank constraint for scene categorization. If you want to run the code, click on the file source code. In the source code, the listing functions will be there. If you want to run the code, please right click on main.m file, click on run file, you will get this guide window. When you click on the load training data, browse your system and select the training set folder which is inside the source code folder. If you select it, means it will contain images under some 5 categories, and for all the images features will be extracted and the images will be trained. So this is the process. So features for all the images were extracted. The features were extracted. Then when you click on the test image button, then give any test image, then do pre-processing. For pre-processing we have used Gaussian filter. The Gaussian filter smoothes the image and eliminates the unwanted pixels in them so that the image will be look enhanced. Then when you click on the button feature extractions, the features will be extracted for the image that you are given as the test. So here shift features were first initially extracted and then GLCM features were extracted, and so the extracted features were saved in this matrix. So based on this feature extraction only, we are categorizing the action of this person. Then we do clustering. So in the clustering process, what will happen means all the trained features were plotted. So each color represents each category of images, such as running, walking, cricket, like that, and the black color rounds represents the cluster centroid locations. And based on this clustering, we are organizing the trained feature values. And then when you click on the classification, the accuracy, and then confusion matrix, and then finally the category of the given image will be displayed. So this is displayed as football, and then a confusion matrix is displayed. So actually a confusion matrix represents the number of images correctly classified in each category. So for the first category, 1 image is wrongly classified and 9 images were correctly classified. In the second category, the given 10 images were correctly classified. In the third category, 8 images were correctly classified and 2 images were wrongly classified. And in the fourth category, 3 images were correctly classified and 7 images were wrongly classified. And in the final fifth category, 7 images were correctly classified and 3 images were wrongly classified. So this is the basic operations of the self-supervised online metric learning with low rank constraint for scene categorization.